There's a lot of people around the world working with honeypots, gaining insights from honeypots, collecting things, understanding. The problem is that honeypots usually are more useful if they are high interaction honeypots. But if you want to extract data from a high interaction honeypot which has been violated, you need to take it offline, perform forensics analysis, do a write-up, post the write-up. Which means it takes time, it takes effort, it takes skill. And the Project ONINET builds things out of this because they have a little time, a lot of skills, people working on that. But what we would need actually is something similar to Project ONINET and ISC combined. Something which is a network of honeypots, of high interaction honeypots possibly, which can be actually automatically analyzed and correlated. How do you build such a thing? We have a few building blocks. I will not go through each of these because I don't have the time, and because probably most of you know most of these tools, and we'll just launch to you the names and the definitions so that if there's something that catches your attention and you didn't know, you can look it up with your own Google later. HoneyD, everybody knows HoneyD, way to generate low interaction honeypots. Great stuff, great things, two problems. One is you have to generate scripts for interaction, and you have to generate good scripts if you want to capture real attackers' activity. And generating a script is a tedious task. And for this, some guys in France generate a thing that is called ScriptGen. ScriptGen is an auto-generator of scripts that emulate a service, which would be a reverse engineer web dream, if it worked actually. It doesn't work completely. It works well enough to generate the scripts for capturing some specific types of exploits. Because when you actually run an exploit, you don't really want to have the full set of a service available. You just want some specific subsets. So basically what happens with a honey farm with ScriptGen is that when a machine with HoneyD doesn't know how to answer to a specific query, it forwards the query to a high interaction honeypot, which afterwards will get analyzed and all the usual stuff. And in this process, it will automatically generate a script for answering subsequent queries similar to that one. There's a similar effort which is ONID. I don't know it. I know ScriptGen better. I suppose they are more or less the same thing from my Googling. Then there are successful efforts, Nepenthes and MWCollect. I don't really need to talk about this. There's Georg Wiekerski, which is here somewhere, and he will talk about it tomorrow or today. I think tomorrow actually. So just go and ask Georg. Why do you ask me? He wrote this stuff. But basically, the idea here is to collect the malware which is sent as a payload of an attack, to store it, to download it, and what? To analyze it, probably. But the problem is that if you run this stuff on a large scale, as the guys from Nepenthes are doing, you end up with a huge amount of malware, which then you need to analyze somehow. And you need probably to analyze it automatically if you want to get any useful data out of it. Then there's another stuff which maybe you know less because it's not as much practical as it's academic, which is Argos. It's a way to build high interaction honeypots. Basically, it's a way to modify QEMU in order to run virtual machines of honeypots and use taint analysis, which is a very difficult word for a very simple concept. If you see something running through the network, and later you see the same something running inside the memory of the computer, then something very bad has happened. If you're executing some code which came from the network, then something bad has happened. Which doesn't actually catch 99.9% of the exploits, but it catches 99.8% of them. And the sweet thing here is that because you are modifying the virtual machine running the code, you can actually run every type of operating system inside. and just get the same results. There's a project called Lerecom, which maybe you don't know, which is operated by Lerecom, which is an institute in Sofia Antipolis. Lerecom is a network of honeypots, covers more than 30 countries, and uses honeypots created with ScriptGen and Honeybee in order to analyze the most interactions possible. You can go to lerecom.org and see for yourself. I don't have a lot of time to get into the details. There's a lot of other projects that I mentioned here, but I will jump through. And arrive to the project that I wanted to introduce to you, which is called Wombat. The Wombat is that awful animal over there. I didn't know it was so awful, or I would have fight against the naming of the project. Actually, seeing it alive in Australia is even more awful than that. So it's better to use this square sign and not the real photograph of the beast. It means Worldwide Observatory of Malicious Behavior and Attack Tools. Basically, it's an idea. It's a research project which has been funded by the EU and by partner countries, and will be starting at the beginning of 2008 with, among the participants, your Technical University of Vienna, the Freie Universität in Amsterdam, my own university, of course, otherwise why would I be here? Some research institutes around the world, certain corporations, a couple of, a large security vendor, which doesn't want to be named yet, and a large internet service provider, which similarly doesn't want to be named yet. The large internet service provider has a name which includes a name of a European country side, so you know there's just a handful that you can choose from. And the large security vendor is really large. And then there's a highly innovative SME, which has no issue whatsoever in being named. It's ISPOSEC, which is the company which runs VirusTotal.com. So you can see why they would be interested in something like this. The idea here is to target data acquisition, so try to develop what I described to you earlier as a network of high interaction honeypots, which will be substantially based upon Argos and ScriptGen and Honeybee, but also on new types of honeypots that this project do not yet incorporate. Basically, the two types of honeypots that we think that need to be developed. Some efforts are already being done in the area, but there's still a lot of work to do. Are client-based honeypots, and in particular, not just developing a client-based honeypot, which is not so difficult or so unresolved, but how to integrate a client-based honeypot inside a network of honeypots such as the one that we are building. And the second idea is to build wireless and Bluetooth honeypots, which have a very difficult problem of needing to be geographically dispersed around the country, which is not so easy to solve. Of course, here the idea is that this project is the last comer on the block. We don't want to arrive and say, hey, we are going to solve everybody's problems. What we want to do here is to try to have collaboration with the other projects that are already collecting data. We have, gathered some support from the EU for improving collaboration. So we are all for improving this. And we will have, we will hold a workshop actually in the early 2008 for all those people and structures that are interested or potentially interested in sharing data or getting access to this data, because we want to create a standard for collaboration. So if you're interested, or if you think you're interested, please feel free to get in touch with me, because it will not be a call for paper open workshop, it will be an invitation-based workshop, but we surely want to invite everybody who is interested in this. Once you have acquired a lot of data, and there's a lot of people who have acquired data, you have the problem of how to analyze it, which is basically the idea that collecting thousands of malware is easy. Actually, it's more than enough to put a clueless Windows user with a clueless Windows machine out there, and you will collect thousands of malware very easily. Then we have the problem of identifying them, of automatically or automagically classifying them, which is more difficult. And the priceless thing would be to be able to figure out who has developed them and why they have developed them, which is the end result that we aim to get with this project. Some of the examples of technologies that are already there that can be incorporated in this is called behavior characterization, the idea of analyzing the structure of code, constructing phylogeny. You can ask Halvar Flake, who is giving a talk tomorrow, not today, about this specific topic. And also, all the contextual information of attacks, that basically are all the informations that today you already collect with ISC or other types of efforts. So, how the attack was performed, types of scanning activities that preceded the attack, the type of deployed payload, which is something that you can do with MW Collect even today, subsequent actions of the attacker. All this data can be used and should be used to automatically characterize and classify the attacks. Doing threat analysis upon this data will be actually doable because until now you don't have data sets where you can do threat analysis on. And it will be difficult. Not in the usual economic or time spent sense of the word, but it's difficult in the academic research stuff sense of the word. So you can see that probably what the academic partners of the project are more interested in is this part. What the infrastructure vendors part are more interested in is the previous part. The idea here, what we want to deliver, and we will try to be able to do that by, well, actually 2010, because this is a 3 years project, is to deliver early warning capabilities, which is simpler, and trying to deliver reports, high-level reports, on what actually the people are doing with this stuff. Which is, if you remember, exactly the first question that I asked during my talk. And so, this is basically a set of milestones, the roadmap of the project, which is in early 2008, the invitation workshop that I told you about. In late 2008 and beginning of 2009, deployment of sensors. By 2009, we will end the characterization phase, and in early 2010 or somewhere in 2010, we will have probably, likely, perhaps, an early warning prototype and root cause analysis stuff developed. This is a joint industrial and academic project, which means there will be a lot of academic publications in it and a lot of stuff which will be developed by industrial partners, and then of course industrial partners will decide how to release it. The data sets, or a subset of the data sets, are meant to be released to researchers in some ways or the other. So one of the key points in this workshop that I was talking about is actually understanding what we will be able to deliver to researchers and what researchers want us to deliver to them. Yeah, okay. I finished. This is my conclusions. So, basically, what I want from you right now is, if you are interested in trying to join this workshop because you have an interest at stake in this type of stuff, please feel free to contact me. I cannot promise that you will be part of the workshop, but I can promise that we want everybody who is really interested to have in there, because it's very important for us. Second thing that I want you to do is, if you have, perceptions or ideas on this stuff, or if you think that I forgot something in my analysis of what is there right now, if you, for instance, think that there's something out there right now that you believe already responds to some of my questions, please let me know, because we don't want to ignore it. We really want to integrate our approach with what is already existing out there. And in the end, if you have any feedback